Hi, welcome for attending today. I'm Gene Albert, CEO of Lexbe, and this edition of our Lexbe eDiscovery webinar series is a Lawyer's Guide to eDiscovery Processing, what you should know to competently handle your case. This is going to be presented by Christian Detrude here of Lexbe. I'm really excited about this topic. We've had a lot of requests for this topic over the years, and I'm happy that we're finally doing it. This coming from attorneys who have discovered that as eDiscovery has become more important in their cases, that the details of how eDiscovery really works, what's happening under the hood, is important in being able to assess what they're doing and the quality of what they receive from the other side, and just to understand when it's gone well and when it's gone wrong and what you should expect from it. So it's we'll try not to keep it too technical for the people that aren't of that side, but try to make the translation so you can see what's really important for you in your case. A little bit about our eDiscovery webinar series. These take place monthly. They cover a variety of topics, and afterwards they're going to be available on demand download by registrants, and we have a PDF of the deck. We do a transcript. There's an MP3 podcast and then a streaming version of that, and they come out in generally about the week or so afterwards, some of it quicker. So these are all available for everybody who has registered and is attending. Just a quick ad about Lexbe. We're an Austin-based eDiscovery software services provider. We specialize in serving small and medium-sized law firms and organizations that have got big cases, complex litigation. Our flagship product is our own cloud-based do-it-yourself eDiscovery processing and document review software that we call the Lexbe eDiscovery platform. We also do high-speed ESI, electronic stored information processing, and document conversion services for other software and projects. And then we have a team of experienced eDiscovery specialists and consultants here on staff that can help. If you have any technical questions during the webinar, please email webinars@lexbe.com, and somebody will get back to you on that and take care of it. Let me tell you a little bit about Christian. He's an eDiscovery solutions consultant with us here at Lexbe. Christian is very knowledgeable about eDiscovery and processing in particular. He's a certified eDiscovery specialist by the Association of Certified eDiscovery Specialists, ACEDS, which is the leading certificating organization in the industry. And Christian also has a background of doing eDiscovery processing and technical consulting, so he knows the details of how this works. And then he specializes now in working with firms, smaller firms and in-house departments handling eDiscovery that are involved in complex litigation, and are looking at ways of making that more effective in their litigation and more efficient working through their cases and projects. So with that, I will turn things over to Christian.
All right, thank you, Gene, and thank you everybody for attending. To start off the webinar today, we'll take a look at our agenda for this webinar. We're going to start with the growth of the volume of ESI. Goals of eDiscovery processing will come next, and then we're going to cover the processing and the overall EDRM workflow, scalable processing, processing steps, both an overview and some details, QC and security during processing, and then we'll touch on how processing fits into document review. This slide here shows the exponential growth of ESI just in the world that we live in today. The digital information created, captured, and replicated worldwide is over 4 zettabytes now. We can see that that's a trillion gigabytes per zettabyte. And ESI, of course, being electronically stored information. As I move to this next slide, we see that the growth of ESI just in our everyday life and in the world is leading to a growth of the amount of ESI collected, reviewed, and brought to trial in litigation matters. For instance, back in 2005, the Enron criminal trial, they brought 40 gigs to trial, which was extraordinary at the time, and now that would be a fairly small case by some standards. So with this amount of ESI that we're getting these days, the large amount of ESI that must be processed, our eDiscovery processing goals we'll cover today in this webinar. Our goals are to extract metadata and support data reduction, and that'll be through processes like denisting, culling, and dedupe. Documents need to be standardized into a review format to allow loading into a review platform. Comply with production requirements or other guidelines for standard production formats and load files. Processing should create high-quality search indexes and support data analysis. Utilize legally defensible processes, and of course be fast and cost-effective. Here we see processing in the EDRM, the Electronic Discovery Reference Model, and processing is right here in parallel with review and analysis. And we notice that it comes after the preservation and collection of the data, so we've got that. We need to process it, and we process it parallel with review and analysis because that's going to support your document review and your analysis of the data, and it's going to save time and money in the review and ultimately in the production. And we see processing coming before production here. Oftentimes production will also entail processing, but a lot of times you do the initial processing that supports data reduction and review efficiency, and then just apply the finishing touches of processing, if you will, for the production side so that it limits the amount of data that has to be fully processed into a production format. So for processing in the EDRM, data volume moves from larger to smaller and less relevant to more relevant along that EDRM model, and that's irrelevant data being removed along the way as it goes from collection, preservation into the processing, review, and analysis side. Processing is needed during that review and analysis phase to promote more precise data reduction, speed the review, and to support legally defensible practices in your review and your data reduction procedures. Review should be done in near native, HTML, PDF, or TIFF. The choice is going to be driven by your review platform's capabilities. And there are trade-offs here. TIFFs are often very large and cumbersome to work with, but that's often what you need to produce in. So then you get to see exactly what the doc looks like in production. PDFs are often a production format as well and match up pretty well with TIFFs, so you can see what your productions are going to look like with those two file formats. HTML is pretty close. HTML and PDF have the advantage of being easy to work with and small in size. And then native and near native, of course, aren't going to give you the ability to see what it looks like out in production because they're not paginated. They are a little bit more difficult to review sometimes, but they're going to be the smallest in size. Processing at this stage in the EDRM facilitates the analysis of the data and the formulation of your review strategy, and the information gleaned by processing and analysis of data during that stage is going to allow for a faster and more efficient review, which will save you time and control costs in the overall project. This graphic right here, this is showing kind of the same thing as the EDRM, and that ESI, ID, and collection comes first, and we've got a high volume and a low relevance of data there. Then where processing fits in is during this early data analysis and culling or filtering. And the early efforts there are going to result in the improved quality and reduced costs in the review and production and the use of the data in depositions, motions, and trial. So we'll move along to this processing requirements overview. Quality, of course, is a requirement of your processing. It needs to deliver usable and complete outputs to support accurate and efficient data reduction and review, and to support the subsequent stages of discovery. Speed and scalability, another requirement. Your available capacity needs to meet demand. Obviously, you need to be able to process all of the data necessary for your case, and the faster that the collections can be processed, the sooner review can begin and the less time will be wasted. Budget, of course, a requirement that the eDiscovery processing expenditure is predictable and within budget. And also it fits into budget because it should reduce your expenditures later in the projects in review and production if processing is done right. And then the final requirement is integration. However you choose to process your data, the output needs to move smoothly into your early case analysis and litigation review platform. And of course, with many modern platforms, that's done automatically because processing can be done within the platform. Here's an example of a scalable processing engine. And we can see the incoming ESI can move through any number of servers in parallel to be processed into the review format, the reviewable documents. And the advantages here are that it's available on demand as needed, and there's no costly setup or wait times. The ESI collections can be broken into pieces and processed simultaneously in parallel server environments. It's scalable, and the bottom line is that this means you're going to get faster processing, and it's going to take you hours from natives to review rather than days or weeks. As we move along now, we'll look at the processing key steps and features. Archive, container, and expansion. This is a step in processing where you take something like a zip or a RAR or even a Outlook PST file, something that's a single file that contains multiple files compressed within inside it. And this processing step takes those containers and pulls out the individual files, putting them into individual document records for review. File repair is another key processing step. This is just the repair of any corruption that may have happened during the collection, the preservation, or during any other stage before the processing to the file so that it can be repaired and become reviewable if at all possible. Metadata extraction and fielding. This is important, and we have some more slides that are going to cover that. Essentially, the metadata is the data about the data, so things like date modified, date sent, who modified it, who sent it, etc. And that needs to be extracted and fielded into your review platform during processing. MD5 hash code generation, we'll touch on in another slide as well. For now, we'll say it's essentially a way of identifying a document, an analogy often used as a fingerprint. So every MD5 hash code is unique to that particular document and will identify if that document is exactly the same as another. System file identification and denisting. This is a data reduction step. This is just the removal of any documents, or files rather I should say, that are known system files on an operating system of a computer. Deduplication, of course, is a key step of processing, and we'll touch on that in detail. Email attachment, extraction, and parent email association. This is the process whereby a single email that has attachments is going to be one file, like an MSG or an EML, and processing will take that file and extract those parent emails and their attachments as children and put them into separate document records and associate them together. So during your review, you can look at an email, see which documents are attached to it in their own document records, and review those as well, and that they'll be linked together in the review platform. The time zone offset for emails. This is important because Outlook doesn't set a time zone for emails. So whatever time zone you view an email in, Outlook automatically offsets from universal time to that time zone. So when you're going to process your data, you're going to want to make the decision of processing it into universal time, your own time zone, or if there are multiple time zones involved in the case, whether you're going to use universal or choose a standard one for all of the email files to be viewed in. Custodian assignment needs to happen during processing. A custodian is, of course, just the person who owns the computer that the data was collected from, and that should be assigned here to support the data reduction or review later on. Native text extraction. This is where the processing engine will take a file and extract the text kind of hidden behind the scenes in that file, and this should be indexed for search, and we'll touch on that as well. OCR should happen as well here on all of the documents. OCR is optical character recognition. It's where the computer looks at the face of the document, essentially reads and transcribes what it says on the face of the document, even if that text isn't selectable or recognized as text in the document itself. And then both of those native and OCR texts should be extracted and then built into an index for search. So we move to the next slide. We'll look at hash values again, which I briefly touched on. An MD5 hash is a 128-bit number, and there's the analogy of the fingerprint that I mentioned before. Every file is going to have a unique hash so that you can identify if they're exactly the same. The hashes would be exactly the same. And so hash values are used in chain of custody and authentication. Denisting, which I mentioned before, the list of NIST files is a list of hash values for all known operating system software. And processing should compare your uploaded files against that list to remove anything that's definitely a system operating file. And then, of course, hash values are used for identification of exact duplicates. And we see here some special issues with emails. PSTs, those Microsoft Outlook email container files, every time one of those is changed, it's opened in a different Outlook, it's edited by somebody, it can change the hash values of the emails contained within there. So that standard hashing isn't going to work for that chain of custody and that exact duplication. So instead, a good processing engine will take emails coming from PSTs and create hash values from metadata strings, which means it'll look at the exact time down to the second that something was sent, something was received, the subject line, the to, from, and so on, and create a hash value based on those so that those things can still be retained and you can still deduplicate and get accurate hash value comparisons for email files that come from PSTs. Touching on the metadata use again, the metadata, as we've talked about, is that field level file information, and we see some examples here of metadata fields: date and time sent and received, sender recipients, CC, BCC for email, and then the doc source file path custodian would also be metadata fields, last modified, file extension. And so a good processing engine definitely needs to extract these fields and field them in your document review database, for one, to support the review and the organization of your case and data reduction, but then also these often need to be delivered in load files when it comes time for production. We see here an example of fielding metadata on this slide, and the email metadata in Outlook, that's what it looks like behind the scenes in Outlook, and then we look at it on the face of the document and it's just a header and text, and then there it is fielded in a database where those fields can then be searched and filtered on during review. Moving along, this is talking about the dual index of both the OCR text and then the native extracted text. And when you index both of those texts, that's going to be the most comprehensive approach. This is going to minimize your potential for lost or unsearchable data. It's going to find more privileged documents, more personally identifiable information, and improve your accuracy and quality of culling. And we see that behind the scenes native extracted text, that's going to grab things that might not appear on the face of the document, like Excel formulas. It's going to grab hidden sheets on an Excel, hidden rows. It's going to grab speaker's notes or document notes from a PowerPoint or a Word document. But then if an image is embedded on the front of the text, or the file has no native text present in it but does have text on the face of the document, OCR is only going to capture that. So a good processing engine needs to capture both and index them both for search. As I move to this next slide, we'll see the benefits of dual indexing here, in that we have the HTML text and the OCR text from the same document, and it's different given those things that I mentioned before. Some of this might have been text-based and some of this image-based, and it's still showing up within one document record, and they're both searchable, as we see that Boolean search that searches for both unique text strings that are only present in one version of the doc or the other. Moving along to reducing documents with culling. The purpose of culling is to defensibly remove files that are unlikely to lead to responsive documents. Denist and deduplication are examples of culling in a way, and denist we talked about, deduplication we'll talk about further. Culling examples would be filtering by file type and date and then removing those documents or suppressing them from review, or keyword filtering, so that only documents meeting certain keywords need to be reviewed. Issues to be cognizant of during culling are keyword selection and testing, concept searching, the documentation of the culling process, which is key to defensibility later, as is the repeatability of the culling process, and then culled file retention. Often you're going to want to retain your culled files either by only suppressing them from review and not taking them out of your data set, or else backing them up before removal from the data set. And reduction during the denisting, deduplication, and culling process might reduce your data up to 95% from its raw size. Moving along, we'll talk about deduplication here. Why do duplicates exist? One example would be collection from multiple stores. Maybe somebody's Outlook and their Gmail, somebody's work and their personal, and so they might have duplicate information in there, but you collect both to be thorough and catch things that are not duplicates. Another example would be duplicates between custodians. If I send you an email and then both of us have our email boxes collected, that same email is going to be present in my sent and your received. So those would be duplicates. Email attachments can often be duplicate if a certain PDF or Excel or what have you gets sent around an office or something like that. And then email chains will create near duplicates. And that would be something where I send an email that's maybe 6 paragraphs and somebody responds back and says, yes, I agree. Now, that's not a duplicate, but it's nearly a duplicate. And that moves us into the type of duplicates. And those exact duplicates are ones that match hash values, like I was talking about before. So in the example where I send you an email and then it's in my sent and your received, those dates and times are going to match, the to and from are going to match. It's going to be an exact duplicate on a hash value. If you respond back and say sounds good, that becomes a near duplicate, the sounds good email. As I talked about, the role of the hash values, it separates exact dupes from near dupes. And then vertical versus horizontal dedupe is a consideration during processing, and we'll talk about what that looks like on the next slide. So this is an example of vertical dedupe versus horizontal dedupe. And vertical dedupe is meaning that you only dedupe within that one custodian. And this may result in less data reduction than a horizontal, but it's also less likely to cause data holes or production gaps. A horizontal dedupe is going to go across all custodians looking for duplicates. It may result in more data reduction than a vertical dedupe, depending on the data set, but it has the potential to cause data holes and production gaps. An example would be, I've been sending you emails. We're both collected for a lawsuit, and deduplication across custodian removes all of the emails that I sent to you because they're still in the database as emails that you received. And then you're dropped from the litigation. Your documents are then not produced or deleted from the litigation document review database, and then those documents are just going to be missing. And so that's something to be cognizant of when deciding a vertical or horizontal dedupe. Back to some processing key steps and features. These are a couple that I didn't touch on in the last slide, and these are some that sometimes are more important during the production side of processing. And so bait stamping, obviously, in most instances, you're going to want to hold off on bait stamping until you've reviewed your documents and are actually sending them out to production so that you can get consecutive ranges. Control numbers can be applied at this time, or they can be applied as the data comes in, just to organize it. PDF and TIFF creation depends on production format, but oftentimes you won't create your PDF, or especially it's a TIFF, you probably don't want to create it until it's time to produce in TIFF because of the large size that those can take up, and they can be a little bit more difficult to work with in review. Placeholder creation needs to take place in the front end, and it becomes especially important during the production. Placeholders are created when something that cannot be represented in a review format undergoes processing. So if it's something like a 3D graphic design file, that can't be represented in a TIFF or a PDF, and so it should receive a placeholder. And then this placeholder is just a one-page PDF or TIFF that describes what the document is. It says placeholder and can be bait stamped and put into production so that that document can be produced natively and have an associated bait stamp and a placeholder within the TIFF or PDF production. Placeholders also are created for files that are corrupt and cannot be processed. Another key step is the load file generation, and of course this is for production. Oftentimes you need to create a load file. Almost every time you need to create a load file when you're producing documents. And so processing that you use to create that production should be able to create these load files for you. You may also need these if you don't have an integrated solution for processing and review, so you can move your processed data into your review platform. Moving along to security, we'll look at the latest security technologies and best practices. Data encryption. Data should be encrypted at 256-bit or above in place and in transit when you're getting it processed. You want to use data centers that are certified. You want clear ownership rights of your data, of course, service agreements that clearly acknowledge client data ownership, you being the client of the processing provider. And then redundancy and backups are going to be important so that you have no chance of losing your data to any kind of natural disaster or anything like that. So I'll move on again, and we're looking at an example of a processing workflow here. And this is a processing workflow where the processing is done in a cloud environment. And so you would log into a secure web account, upload your native ESI. You would QC that the custodians, time zones, etc. have been set properly. And then you would export that processed data as natives, PDFs, or TIFFs, and then load it to your review platform. Of course, if you have an integrated processing and review platform, such as the Lexbe eDiscovery platform, the data is just available already. You can skip that export step, and you're ready for review as soon as you upload. Once your data is processed, you of course need to review that data. And this slide just shows a data review option, the Lexbe eDiscovery platform, and some of the features here like self-administration, the native processing, and automatic OCR. And you'll notice some of the features that we talked about is some of the necessities to processing, like a dual index and deduplication. So in summary, for the webinar about eDiscovery processing, we see that processing is an essential element of discovery and the foundation of high-quality reviews. Processing procedures must be legally defensible and result in outputs which comply with the requirements for your case. Scalable processing solutions are crucial for meeting deadlines and controlling costs. Processing done right, and it should include a number of basic steps that we talked about, such as the metadata extraction and fielding, that MD5 hashing, the extraction and dual indexing of HTML and OCR text, and these steps and more that we talked about earlier in the webinar facilitate the fast, accurate, and defensible data reduction and review processes that you need. And that processing done right saves time and money in the overall eDiscovery process by facilitating data reduction and review efficiency. And with that, I will turn things back over to Gene.
Thanks, Christian. That was really interesting. Thanks for going through all that. And I want to thank everybody for attending. We will be making the collateral materials available to webinar attendees in a couple different ways. One is we'll have a webinar PDF deck that we'll make available, be able to have fairly quickly. Then we'll have a streaming video version and an MP3 podcast available that later, and then eventually a transcript. So all that will be available if you'd like to get some more information on this. And if any other questions or comments or requests, please let us know at webinars@lexbe.com or contact Christian or me directly. And hope to see you on our next monthly installment. Thank you.